In this problem, we have an 80-kilogram baseball player running at 4 meters per second, slides into second base. If it takes 0.65 seconds to come to a stop, what is the net force of the baseball player? We're going to use the impulse momentum theorem to solve this problem. We're going to start with our picture of what's going on. So a baseball player sliding into second base. We're given the mass of the baseball player to be 80 kilograms. We're given that the player is initially running at 4 meters per second. And then eventually comes to a stop. It takes a time of 0.65 seconds for all this to occur. We want to find what is the net force acting on the baseball player. Okay, the impulse momentum theorem states that the change in momentum is equal to the net force times the change in time. Now I'm going to write this out a little bit differently because this change in momentum, again, momentum is mass times velocity. But we're finding out how much it changed, so we're going to subtract the final momentum and the initial momentum. And that is going to be equal to our net force times the time. At this point, we have everything we need here to solve for that net force. We have our mass is 80 kilograms. Our final velocity is 0. Our initial velocity is 4. So make sure you have things in the right order as well. It's always the final minus the initial. And that is equal to our net force, which is what we're trying to find, times the time, which is 0.65. This over here comes out to be 0 minus 320, or negative 320. And then we divide each side by the 0.65. We got to get rid of the 0.65 connected to our variable. And we get that the net force comes out to be a negative 492.3 newtons. And the question might be, well, why do we get a negative force? And the reason we get a negative force is because if we consider our velocity to be positive, the force must be in the opposite direction to slow the object down, in this case, to slow the baseball player down.